walkthrough. Next, please. So again, we for the mining portion, we're looking at .NET Core. Why? Because once we have this working, can this also go on Linux? Okay, maybe. We're definitely going to use the AMQP protocols. Why? Because we're going to have guaranteed delivery. We want to make sure that if we are analyzing your software down below, we have it automatically sent to the cloud. It's guaranteed to get there. And as much as possible, we're going to use open source common approaches like JSON. You see there for the moving aspect, Azure Event Hubs. What is that? That's essentially Kafka. That is one of the most popular ways to take streaming information. For example, a lot of IoT devices will stream consistently. How do they do that? With event streaming platforms like Kafka. This is Microsoft's version. So we capture everything there. Then once we capture it, we automatically start curating it into the different data stores. We're going to take what's known as a data lakehouse approach. The data lakehouse approach is essentially, think of it as a big bucket, and within there, I can have different data lakes. So we can do analytics, we can have a data warehouse, we're going to have Azure in there, we're going to do blob storage, because quite often we don't know what we're going to collect eventually. So let's just collect it all, okay? So big platform, data lake house with data lakes in there to do everything we need. And then finally, the front end and reporting it, we want to be very open. Whether you want to use the microservices within your software, you want to just grab this for pulling your own data, we don't care. Power BI, we're going to hook up Power BI to automatically allow people to start seeing what's possible. And it's going to be, very lightweight HTML, CSS platform that people can extend. And we think the real power is the microservices. This is your data. Use it how you want as much as possible. Next slide, please. So the major steps, we have agents that are sitting down at any of your devices. It grabs all the file properties that we can for each binary. When it finds another binary and the path that it belongs to, it'll then grab that. It'll then actually look at, hey, do you have any children? It'll mine those. If that has children, mine those. But start gathering up all this metadata, very easily push it to the cloud. And there you go again. It's available, like we said, for those different data buckets into whatever form you want it. Use our dashboard for reporting, microservices, or Power BI. Next slide, please. Finally, the outputs. The way we envision the outputs is really just data availability. That we look at this as an ecosystem type of approach to serve up any agency, any organization, anybody in the sectors that are listed within the EEO. It's just data, serve it up to them, and then they can bang away at it with AI, ML, which we'll be doing too to help out, and any basic tools out there. Next slide. And that's it, unless there's any questions.
Okay, so great job. And we're gonna fix an error that we made on our side. So what we're gonna do is we're gonna launch the poll for disruptive ops and Iron Pipeline while we're going through Jonathan's questions. After we're done that and we finish the disruptive ops section, we're going to go back and relaunch the Ion Channels survey. So I apologize about the misstep there. Jonathan, will your solution produce findings other than potential threats and weaknesses of binaries?
Yes, I think one of the big keys is really about the data which is in there. For example, if we know who the supplier is, which is in there, can we start using that, descriptions, version numbers? Essentially, can we find patterns in those 40-some typical properties out there to start finding patterns to say, hey, you know what? Good actor, bad actor, we don't know, that needs investigation. Because especially within the federal government, let's say we have a particular vendor that continually produces, flawed software. Wouldn't you like to know that across not only the agency, but across the government? So starting to understand these things and be able to bubble that up, that is just humongous awareness, whether it's gov, banking, or anything like that, using that metadata.
Yeah, that makes sense. What is your plan for continual improvements?
So that's a real key there. We are going to continually look at the data and see how the data can say, hey, you know what, this is a risk, this is not a risk. We're trying to, as quickly as possible, After we identify these binaries, making sure that we limit the action that you need by making sure it's very positive. Hey, you really got to do something on here versus, you may have to do something on there. We're going to continually look at the time to response, because this will be able to say, hey, here's a risk. How long is taking you to address that? Because maybe we need better actionable information for you. We want to continually work with Microsoft. It's another great example. These are all Microsoft binaries in whatever language. Hey, Microsoft, help us out here. What else can we know? We have Windows 11 that started showing already. How's that going to differ, right? Don't we want to know that right off the bat? So working with Microsoft and key vendors is going to be a huge one. So we see to continually build the ecosystem of data, so we understand what's really out there as far as open source and commercial software like Windows, and then going forward.
That's good. So Robert's asked a question here. Into which product category do you most believe your offering fits? SCA, SAST? How do you position against something like Veracode?
Okay. So we see this as, again, more of an ecosystem type thing. We see this as sitting on your device. We can actually have it so that it's scheduled to run, or potentially just, hey, I saw something in your OS, now run it again. We get the data, we serve it up, and then once it's into the cloud, working with those other vendors and say, okay, how do you want to use this information? So again, it's grabbing it, having the cloud tie in with whatever third-party tools are in there, your build, your security, whatever it is, and then make decisions from there. So it's, again, ecosystem, heavy focus on interoperability with the third parties.
Okay. All right. I'm going to ask the audience for their polling to continue submitting the polling. It's quite important for the whole program. And then I'm going to come back and ask you another question here, John. So besides the waste, opportunity, and risk engine patent, is there anything else that's patentable?
Yes, well, we believe the mining processes. Many years ago, Microsoft actually started a project to actually start mining their stuff, and just kind of went away. Then there was a third-party tool out there for a little bit that ended up going away as well. And so there's some flaws that are out there. One is it's not complete. We recognize that we don't want to get into a circular process, meaning we may mine something and then, hey, it may have these other children, grandchildren, great-grandchildren that we already mined. So we need to find a way to very quickly mine only what we need to, be smart, and say, hey, I can trust the rest of that stream, get downhill. So it's going to be that mining process that we look at patenting as well.
All right. And then the last question, can you describe your approach to verify and validate interoperability?
Yes, I think the big thing is really to have a true microservice approach. What is that? It's not SOA, right? It's not a gathered of services. It is just, hey, you want this data, here it is in a single microservice, so we can tie into whatever. If you're making SBOMs, here's all the data you want. I don't care what you want. Here it all is. We have it all in a dictionary form. You use it as is. Making sure that, they're true microservices, making sure you're using JSON, making sure we're continually talking to third-party vendors, governments, industry standards. How do we make sure we can actually integrate with them as much as possible, so that, again, they don't have to change much of what they need, but they can get the data